Hi everyone, it's Marianne again, your instructor for your course. Hopefully by now you have finished Module 1 and you have a good idea of what we mean when we're talking about STEM. And I don't want you to be nervous because you might be thinking, I'm a math teacher. I just wanted to sign on and learn new methods to teach math. Or I'm a science teacher and I just wanted to learn new methods to teach science. But hopefully you figured out by now that STEM is a way of teaching math or science. And from my experience, I feel it's one of the best ways of teaching because of the connections students make between our disciplines. I have to tell you, as a science teacher, and I do a lot of labs because I think I said at one point, I'm more lab and inquiry based. My mantra is teaching content through inquiry. So I like kids to construct their own learning, but where I fall short is sometimes I'm not as explicit and I don't lecture as much and I don't give kids the information they may need to be successful. So I have to balance all the time with lessons, direct instruction, and vocabulary, and making sure they get what they need before they can be successful in the lab. But I can't tell you how many times I hear, this is science, what are we doing math? And that's, mostly from the seventh graders, but most of my students, after they get to know me, understand, that math is the language of science and we really need math to analyze our data and look for trends and patterns and to describe those trends and patterns using math. And I'm not sure what happens in a math class. It's been a long time since I taught math to seventh graders, but I'm sure, in math classes you're hearing, why are we doing this? We have a custodian at my school who always says, I've never had to find X. As an adult. So she's referring to the math, in math and algebra, solve for X. And so she makes me laugh because she's like, I still have never had to find X. But, math is all around us in our daily lives. So there's an example of people not seeing where it's relevant. So STEM helps make those connections and helps, or teaching using STEM as a guiding principle, I guess, is helps make people and students see these connections. Okay. So I just, right now I'm sitting on the floor. So what I want to do is start module 2 with talking about, I think our guiding question is, what are the STEM practices? And then how do we bundle practices with the standards to make the most out of our time with students because we have limited time. And again, I don't know, I haven't met you yet. So you guys who are taking this class, so I don't know what your classrooms are like yet, but I'm going from the assumption that maybe a math teacher is thinking, oh, what do I have to do now? I don't have supplies. But I'm going to show you this is just one simple way to get some numbers and maybe engage kids. So I'm going to show you what I'm doing here. I'm not at school, so I'm at my house. So I found this crappy old meter stick. So the numbers are not really good. So it's hard for me to see them. And I found a little ball and I just taped the meter stick to the wall. And what I was wondering was, this is a potential kinetic energy problem. So for the science teachers, they know that how is drop height related to bounce height? So if I take this bouncy rubber, I think it's rubber ball, and I put it at 20 centimeters, and I have to be very careful. I'm going to try to put it right at the line, and I drop the ball. What is the bounce height? Then my question was, okay, if that's the case, what if I put it at 40? Oh, geez, I can't even see on here. 40 centimeters and drop, just let it go and drop. Is the bounce height double? So is the bounce height double that of 20 centimeters? And then I went to 80 centimeters and did the same thing. So you could get your kids, just get some meter sticks, get some bouncy balls, and ask the kids to the same question, what's the relationship between drop height and bounce height? And interestingly enough, this led to another issue. So you notice when I'm dropping the balls, like I can't see. First of all, you need a couple kids because you can't. It was very difficult for me to drop the ball and measure the bounce height at the same time. But in science, one of the things the science teachers are like, oh, she's a science teacher and she's not keeping things constant. We try to teach kids, like if you're going to collect data, like and your independent variable here is drop height and your dependent variable is bounce height, then nothing else should be changing. So whoever is dropping this ball has to be very consistent every single time and not pushing, like not applying any other force, just literally dropping. Ideally, we would have a contraption that would allow you to just drop, but we don't have time for that. So, we're going to be as constant as we can be. And the same thing at the 40 centimeter mark. Okay. Then you can obviously see the other problem. It's very difficult to accurately measure the bounce height. So what did I do? How did I problem solve that? Well, I took out my cell phone, and most kids have cell phones, even the younger kids. And I would not tell them this either. I'd make them figure it out. Once you give them the task, like, collect some data on looking at the relationship between drop height and bounce height, then the next thing I would have them do is figure out, well, okay, we have a problem now. We can't accurately measure bounce height, but what did we use? The slow motion setting on my cell phone. And I'll just show you one of them. It's funny because you can see me. I have no clue what I'm doing here, but I had to hold so you can see. And then it's slow motion. So I'm holding it for a long time there, but then you'll see the drop. And then I just stopped it I did. To get the measurement, I just stopped it. And you can just replay that. So I'm just going to go back. And the kids can just stop it at exactly that moment when the ball is at its highest point and right at the moment when it's about to drop down. And then I zoomed in and I was able to record that value to the nearest millimeter. So for a 40 centimeter drop height, for a 20 centimeter drop height, the bounce height was 14.4 centimeters, okay? So I did that for just 20, 40, and 80 centimeter drop heights. And in fact, it looks like that and notice my table doesn't have any units, which is not good. It's just this quick little jotting down of numbers. So it does double. Like if I go from 20 to 40, the bounce height goes from 14.4 to 27.1, which isn't exactly, it should have been 28.8. And if I go from 40 to 80, the bounce height goes from 27.1 to 52.5, which again is not 54.2, but it's close. And what if you have a bunch of kids doing this? Then you get a lot of data, and then you can take an average of the data and look at the correlation between drop height and bounce height and graph the data. So I'm going to stop there in this video because this video is already longer than I planned. But we're going to be talking about this little experiment, these numbers, and in the rest of this module. And maybe on one of our Saturday sessions, we can do some of these types of little experiments and see, how can you expand them. But I'm going to leave you with this. Math teachers, think about, I don't know what grades you teach, 5, 6, 7th, or 8th, but look at your math standards and see how many math standards we are connecting to in this one silly little bounce height activity. And then science teachers, same thing. Look at your 5, 6, 7th, and 8th grade science standards and see where we're connecting here. I know we're connecting to kinetic and potential energy, but see where else we're connecting. I'm going to this is going to be part of your task this week, but I just needed to give you some basic little experiment to work off of. So I will see you soon. Good luck.